Lorentz theorem. So today we are going to discuss about that the unit step functions and the unit impulse functions. Okay, so this is the major role. Okay, it have the major role in your solving ordinary differential equations. Okay, so while we are using Laplace transforms only able to solve, because in your differential equations, suppose we are assuming that y double dash minus 3y dash plus 2y equals to, suppose some constant or some algebraic functions, okay, like t power n or e raised to the power at, then sin at, cos at, this kind of standard functions we can solve by our method of variation parameters, and as well as this tan at, cotangent at, secant at, and then cosecant at can be solved by method of variation. Method of variation. This can be done by method of undetermined coefficients, and all this can be done by method of variation of parameters. Suppose the right hand side functions f of t is delta of t minus 5, okay, or u of t minus 8. Okay, so suppose it is there. This is called unit step function, and this is called unit impulse functions at the point here 8 and here it is 5. Okay, then how can we solve this kind of non-homogeneous ODE? Okay, that we cannot solve by our existing methods. The variation of parameters are undetermined coefficients. So the only process is we have to apply the Laplace transforms. Laplace transforms. So the limiting case are the initial value point. Okay, at some point towards the right and left, if you are finding the limit, it has some discontinuity functions. So that time we need to solve by this Laplace transforms only. So okay, so we will see. So first, what is unit step function? Okay, unit step function. So first concept, unit step function. Unit step function, or sometimes it is called as Heaviside. This is the inventor name. Oliver Heaviside is the his contribution is for this definition for the mathematics. Okay, Heaviside function or Heaviside unit function. Okay, so it may be denoted as either U form or this H form. Okay, so the unit step function, okay, the unit step function u of t minus a is u of u minus t minus a, or h of t minus a is defined as follows. So how can we define? So u of t minus a, or sometimes we may denote it as h of t minus a. This can be written as so up to this point, from the left end to okay, so when t strictly less than of a, so up to that point the function value always 0, and if it is t greater than or equals to a, at a point or more than of that, value becomes 1. Okay, in graphical manner, if you want to check it out, okay, suppose this is my t, and this is my actually u of t minus a, so the graph of this one is here. The functions, suppose this is my a, okay, this is my a, okay, after that my function has the values here. After that my function has the values here, it is 0, and suppose this is the value 1, means from a onwards it is 1. Okay, for example, can you say that u of t minus 5, the graph of this function, this is t, and this is u of t minus 5, t minus 5. Suppose this is the 0.5. So here, suppose we are having, sorry, this is 1. Okay, height 1 in u of t minus 8. So up to this, here we are having that, 0. 0. Then here, and then E5 and afterwards, it has the unit step value 1. Is it clear?
Clear, sir.
Okay, now, where? You may ask, sir, can I get this u of t minus of minus 2? No, no. The answer is no. So always it should be greater than 0. So you are where a is positive. A is positive or equals to 0 and otherwise. Okay, 0 and 0 means up to this. Okay, up to this arm. Okay, it is also denoted as, or sometimes this can be written as u a. Okay, the some other words based on the different textbooks, it may be denoted as HA or U at A. Means at this point, up to this point, the left side values are 0. Then up to after this point onwards, it has the height 1. So that's why these are the 4 notations for our unit step function. Okay. Now transform of unit step function. Transforms of unit step functions. Okay, just this is the property wise I am going to discuss. Just assume that Laplace transform of this unit step function is, what is the definition? The result is e power minus as by s alone. Okay, so this is the result we have to remember. Proof for exam no needed, but I will give. Okay, Laplace transform of u of t minus a is e power minus as by s. Okay, then how can we get, see, Laplace transform of u of t minus a by the definition, it is 0 to infinity e power minus st into my function is u of t minus a, my function is u of t minus a into this, here it is dt by the definition of this u of t minus a. So if you suppose this is my a and this is a height 1, means here onwards it is 1, so here it is 0. Okay, so this is my u of t minus a. So how to find this? Okay, so we may split into that. This integral 0 to a e power minus st. This u of t minus value function, it is 0. Then plus a to this infinity e power minus st is, it is becomes 1. So what is that? If you are integrating, this is 0, this is 0, and this is e power minus st upon minus s 0 a to infinity, so that it is minus 1 by s into e raised to the power minus infinity. Then here it is e raised to the power minus as. So the value becomes, so what is it, sir? The value becomes this integral, this is minus 1 by s into 0 minus e raised to the power minus as. So finally it is e power minus as upon s. Is it clear? So this is no needed for your understanding purpose, just I gave it. So Laplace transform of u of t minus a is e raised to the power minus as by s. Is it clear?
Yes, sir. Yes, sir.
Okay. Suppose the product I am going to assume that, okay, the product I am going to assume it in my unit step function or heaviside functions. Okay, so what is that? We know that u of t minus a is 0 when t is less than of a, and it is 1 when t is greater than or equals to a. So here we are going to multiply with this function. Okay, with this function. So can you say that if it is f of t minus a, the formula? Suppose I am going to multiply. Suppose any function I am going to multiply with this u of t minus a. Then what will be the changes here?
Sir, we have to multiply with f of t, sir.
This f of t should multiply on these two things, right?
Yes,
On
sir.
these things. Suppose this is my a and this is my height. So this is 0 and this is 1. Okay, so this is 1 according to my u of t minus a. Suppose if I am this f of t minus a, I'm going to multiply. So this function also will obey that whatever, this is the 0 function until this a, this is 0 value. So f of t into 0, this function is also taking the value 0. Nothing but this f of t into 0. Then what about the resultant? It is 0, right?
Yes, sir.
Yes, sir.
Then this f of t, whatever the functions, if I am going to multiply with this one, so this kind of nature I am going to get it. The actual nature of my functions I am going to get it. So the graph of functions will act on this in this way, f of t. You got the point?
Yes, sir.
For example, if the graph analysis I'm analyzing it, okay, for example, u of t minus 5, sir, u of t minus 5. So or u of t minus 0, shall I consider this is u of t minus 0 or 1? So what is that? T less than 0, it is 0. T greater than or equals to 0, it should be 1, right? Let f of t is t. I'm going to assume that f of t is t. Okay, then f of t into u of t minus 0 or u of t, this is nothing but t into u of t. Am I right? So graph, tell me, sir. So up to this 0, right? The point here it is defined, it is 0. Up to this, the left side value it is 0, right? The here onwards, the function should be act. So it is 1 into this f of t. So the graph of these functions will act on this. This is my t into u of t. Is it clear? It has the jump discontinuity we are having. The discontinuity, that's why here we are having that we need the heaviside functions. Okay, at 0 onwards, definitely the left hand side limit and right hand side limits are not same. Okay, is it clear?
Yes, sir.
Okay, I hope you understand the points. Okay, problem wise it is easy. See, just you are going to have this L of u minus t minus a means this one. Then what about this L inverse? Can you tell me? Suppose I am going to remove this. L inverse, parallel I just give this. L inverse of e power minus as by s is this a, whatever the function exponential divided by s is we are going to write that is a unit step function at the point this a, right? Am I right? So these are the definitions for inverse Laplace transform. Okay, once if you know these two things, then the problem is very easy for solving the ordinary differential equations or finding the Laplace transform, inverse Laplace transform. That is very easy. Okay, but the concept is very, very important. Why we are needed this heaviside function? Okay, the function f of t minus a into u of t minus a. Both the terms, this function is also having the delayed term, and this function is also having this term. Okay, so it represents the graph of f of t. Okay, this functions represents the graph of f of t, the function's actual f of t. This functions shifted, okay, through a distance a to the right and is special, and it is special in the modeling the problem. Okay, in the natural phenomena it may occur. Okay, so we need this concept. Okay, the concept is now shifting property. The second shifting property, if L of f of t is f of s, then Laplace transform of f of t minus a into this u of t minus a is what? If L of f of t is f of s, then with these functions, this t minus a, t is replaced by t minus a, and also multiplied this u of t minus a. So Laplace transform of f of t minus a and u of t minus a is here we are going to have it. Here we are going to have that e power minus as. This a should take outside of these two. This a we are going to take from both the functions e power as. Remaining it is L of f of t. Remaining this e also will vanish. Once this a, if you are taking out, then this f of t only we are having, so that e power minus as f of s is the corresponding value. Yeah, we will discuss with some problem. See, suppose find Laplace transform of this sine of t minus 3 into u of t minus 3. This value should be same, otherwise the a should be same, otherwise we have to maintain, or we have to add and subtract to make this as the common number. So this is by according to this second shifting theorem, this 3 should be taken out, so e raised to the power minus 3s, remaining L of f of t, so L of sine t only here we are having that, so that now it is e raised to the power minus 3s into this, what is that, into this 1 divided by s square plus 1. So overall that e raised to the power minus 3s upon s square plus 1. Sir, is it clear?
Okay, yes, absolutely.
Yeah, inverse part also, if you are applying that, this one, inverse, if you want to compute, find L inverse of e raised to the power minus 3s divided by s square plus 1. In this case, you have to understand one concept. These exponential functions never be discussed in the numerator in your inverse Laplace transforms. Am I right?
Yes,
Sir, is it there? Okay, so this can be considered it as e raised to the power minus 3s 1 divided by s square plus 1 plus 1. So you may apply the convolutions part for this one, convolution of these two things. Okay, convolution things. I will do in the two ways. Okay, for understanding purpose. Okay, by convolutions, what will we are having that, sir? By convolutions, so this should be product of two things. So one is e raised to the power minus 3s means, what about the corresponding function? We do we have that Laplace transform of inverse Laplace transform of this e to the power minus as? If it is L inverse of 1 divided by s plus a, means the corresponding function may be written as e raised to the power minus at. But L units of e power minus as, do we have?
Yes.
No. So the convolution is no choice here. So the product is not applicable here. So in this way, if you are applying this L units of e power minus 3s means, so just I am trying to get this accept this function. So sine of t, this one, sine of t, and this t will be replaced by t minus 3 with unit function, with the unit step function, with the unit step function, so that we may do it. It is sine of t minus 3 into u of t minus 3 will be the answers for this. If you are applying inverse Laplace transforms, okay, we will see some problem based on this. Okay, and the Laplace transform this same thing. Okay, the same thing for the graph wise we are going to discuss. Okay, so express sometime the graph will be given. Yes.
So in the previous problem, can you explain how you got 17?
Actually, this kind of functions, it comes under inverse Laplace transform of unit step functions. So the detail here, once if you are taking this 3 and 3 here, this e power minus 3s we written, and directly you are writing the L of this sine t alone. This u is you are not going to write here, right?
Yes,
While
sir.
taking Laplace transform, like that while we are taking inverse Laplace transforms, this exponentials you are going to keep in the outside of that, whatever you are having the remaining things. Okay, just keep it in the outside bar. So remaining L inverse of this functions I am going to find. So this is my f of t. So here actually we are getting this f of t. This f of t should replaced by t divided by t minus a. Then this a where it comes, it's because of this exponential function. So this f of t, not only this t is replaced by t minus a, and also these functions also we are going to multiply. Regard the point?
Yes, sir, I got it.
Yeah. So that's we are doing it here. Okay. Now express the function, or the graph. Okay. Express the following function. So something it is given under the piecewise form. Okay, with the graph is given. So the graph is taken at it is t, and this is my f of t. So in this part, suppose I am going to have up to this 1. Okay, up to this 1 we are having this, it is 0, and I am having some ramp. I'm having this ramp, and maybe this point, maybe suppose if it is 2, then here onwards it have this height, it is 1. Okay, the here onwards it is the height will be 1. So in this way it is the function nature having that. Okay, so in terms of our job is to represent this graph or this function in terms of unit step function. So how we are going to write the given function as unit step function, and after that, after representing it as unit step function, find its Laplace transform. Find its Laplace transform. Please remember that the concept is very important. Many of your tutorial sheets problem involved this kind of things. So something it is given by f of t in your ordinary differential equations problems also. So here we are having this solution format. So what about this function f of t? Just to try to write my f of t first. This is my t and t versus f of t. So what is my f of t? When t up to that less than 1, it is 0. Am I right? Am I right?
Yes, sir.
Okay. So if I am interested only this 0 onwards, 0 onwards, so that my graph is, suppose here I may restrict that 0 less than t less than 1. Okay. So this is okay. Then this one ramp one is the slope is positive and it is linear. So line format t, where it is having the slope at 1, so t minus 1, so 1 less than t less than 2, am I right? Students?
Yes, sir.
Okay, we are having that is t minus 1, or otherwise if you want to compute this is 1 comma 0 and it is 1 comma or 2 comma 1, the point from the 2 point you may frame this equations, that is easy. Okay, and then more than 2 it is 1, right?
Yes, sir.
So this f of t, how we are going to write in terms of unit step functions, that is the next choice. Okay, one second. Can you see the window? Students?
No, sir, we cannot
Sir,
see
can you
any window.
explain that again, sir?
Which one, Pa?
That f of t, sir.
One second. I just take one snap. Okay, so we need it. You need this f of t. One second. Wait, it's not coming. Once again, I will give one definition. Can you see the other window? This one. So what you can see now?
Sir, we can see the whiteboard only.
Whiteboard
You are,
only.
you- you're only
Okay.
sharing the whiteboard, sir.
One second, one second. No. Actually, I am not sharing that. It's coming. One second. Okay. To write that, we need one definitions. That's why. Okay. So what is your doubt, Pa?
Sir, explain how we got that, sir.
How it is one now? Okay, I will write this function. Okay. Just look at the graph of this function. Okay. Graph of these functions. So what you are having? So 0 less than t less than 1, the function graph has value 0, right?
Yes, sir.
Okay, now 1 to 2, it's a ramping one, right? T minus 1. Is it clear?
Yes, sir.
Then t greater than 2, the maximum height of the function, it is 1, right? It is constant function. Is it clear?
Yes, sir. Yes, sir.
The one is given, right? So now, okay, so here we need a definition. Okay, we need a definition. It is called pulse. Okay, it is called pulse. Okay, so what is meant by pulse? What is meant by pulse? Okay, a pulse is the function. A pulse is the function which has the form k into Heaviside function h of or u of t minus a minus h of t minus b t minus b. Okay, in which this is the condition. Okay, this is the condition for your pulse. Okay, here in which a less than b. So in this interval form, when you are having this interval, this is my a and this is my b, where t lies between this a and b, so that this functions can be written as, whatever the constants are these functions. Okay, where k is a non-zero number. Okay, where k is a non-zero real number. Suppose we are assuming that. Okay, where k is a non-zero real number. Suppose we are having that. So these functions can be written as in this way. Any functions, this f of t can be written as h of t minus a minus h of t minus b. Okay, so these definitions we needed for these functions to overwrite these functions, or this f of t is to be converted as unit step function. Sir, the problem is here, it is very simple. I am having a functions f of t. So this functions f of t I am trying to write in terms of unit step functions. This f of t is going to be written as in terms of unit step functions. So that's the concepts here. Okay, that's the concepts here we are going to write. See here, my f of t is, now I am going to write in this way. So this is 0. So whatever I am having is 0 into h of t minus 0 minus h of t minus 1. Okay, both are same, right? It is 0 value only, 0 into this. Then plus my function is here in terms of this k. In this pulse functions, I'm going to use this k. And remaining it is what? How can I write? It is h of t minus 1 minus h of t minus 2. Is it clear? Using these pulse functions, in these functions, suppose t is defined on this one, this k is here, this f of t here we are having that. So this t minus 1 into h of t minus 1, the lowest value, and this is the upper value. Have you got the point?
Yes, sir.
What is A and B, sir? Like, what is
Here,
focus in?
see, here what is t lies between this a and b, right? It's an interval, right?
Oh, okay, so like for the final one, it will be 2 to infinity.
So here t lies between 1 and 2. So that's why here in terms of this a and b will be replaced by this 1 and 2. Right?
Yes, sir, got it.
Now here this upper bound value only we are having. Actually here this, if you look at this, this t is taking value more than of 2. Okay, on 2 onwards the function has the value. Here it is, this is my 2. So it is up to infinity. Here we are having that 1 only, right? The height of the functions will be 1. Okay, so here we cannot write h of t minus infinity. We can't write this t greater than 2 as h of t minus infinity minus h of t minus 2. This we can't write. Okay. So the only thing is what at this point 2, the 2 here we are going to write this pulse functions as only whatever the constants are this on that interval, the corresponding functions it is defined. So when t greater than 2 it is 1, so that this 1 into h of t minus 2 only I am going to consider. So this is the concept. Okay, to rewrite a functions in terms of this heaviside function. So overall my function is right now it is t minus 1 into h of t minus 1 minus h of t minus 2 plus h of t minus 2. Okay. Is it clear?
Yes, sir.
Okay, but while you are taking the Laplace transform of that, our function and that the point should have the same value like t minus 1, and as well as h of t minus 1 like that only. So for that reasons we just try to modify here itself the functions f of t. Suppose this function t minus 1 I am going to consider it as t minus 1 as t minus uh, 1 and then t minus 2. Shall I use that? Actually, here first I write so that you can understand. So this is no issues, right? This t minus 1 into h of t minus 1 is not an issue. Am I right? Is it clear? So this is t minus
Yes,
1
sir.
and as well as h of t minus 1. Both it start at the value at 1, not an issue. But here we are having that it is 1 and here it is 2, here it is 2. Okay, so if you are adding these two, so what will be the answer?
Sir, minus t minus 2 h t minus 2
Minus,
t minus 2.
how it is 2 comes?
Sir, like we are adding no, sir.
This
H
one you
of
are going to add with this, right?
yes, sir.
This one you are going to add. So overall that minus t times h minus 2 plus here 1 time h minus 2. Here it is always, here also 1 times it is h minus 2. So it is plus 2 times h minus 2. Are you got the point?
Yes, sir.
So your f of t is, initially we have this kind of function, we are having this kind of functions. Now this function is transformed in this way, this h of t minus 1 and this h of t minus 2, where these 2 points are same. Okay. In this way we are going to write. And not only this t minus 1 and all, suppose I am having that functions, in terms of the trigonometric functions. Okay, express f of t, express f of t in terms of unit step functions. Okay, express f of t in terms of unit step function. Okay, and find find its find its Laplace transform. So what is my f of t? The given f of t is when t greater up to that 0 less than or equals to t, pi is my function is I am going to consider it is sine t. Okay, then pi less than or equal to t less than 2 pi. This is sine 2t. This is sine 2t. Then 2 pi less than or equals to t Okay, now okay, it is more than of that 2 pi, right? Meaning begin that it is more than of t up to infinity. So this is sine 3t we are going to assume. So how can we write using that impulse? Can you tell me that f of t can be expressed as sine t times h of t minus 0? Am I right? This is sine 2t h of t minus pi minus h of t minus 2 pi. Is it clear? Students say yes or no?
Yes, sir.
Okay, now we have to adjust these things. So this sine t ht not an issue, right? This
So
is
can
sine
you
t.
scroll up for a bit? 1 second, sir.
Once again.
Yes, sir. Thank you.
So at the end of the class, in every class you are getting the material, right? It should be in the biggest letter I'm going to write.
Yes, sir.
Yeah, okay. So we can write in this way. We can write in this way the function. The function. Suppose I am going to write this also. So actually, in this type font we are writing means no need to ask that show that the previous slide and all. Okay, this is h of t minus h of t minus pi. Yeah, I may write here. Okay, now, so how to write this?
The sin t, h of t.
H of t is not a matter, as it is we can write sin t alone we may write, or h of t also we may write. This can be written as sin t alone. Okay, so not an issue. So for understanding you may write h of t also. Okay, not an issue. Then here
Sin 2t minus sin t.
sin 2t. Okay, you are gathering. First I just multiply further because some people they want to understand the things. Okay, here it is sin 2t h of t minus pi minus sin 2t h of t minus 2 pi, then plus sin 3t into h of t minus 2 pi. Now from this, if I am going to write, this can be written as sin t. Okay, then plus I'm going to take this h of t minus pi as common one. So remaining it is sin 2t minus sin t. Is it clear? Students?
So how are you writing h of t into sin t as sin t itself?
Which one, ma?
H of t into sin t, how
This,
did
this,
you write
this
it?
you are asking,
No, so before that.
this one. This h of sin t into h of t,
Yes, sir.
This does not make any sense, right? Any problem. This is at 0, right? Actually, the graph of this function is what? H of t is it is 0 and 1. Okay, sin t ht means here it is 0 and here it is sin t when t greater than 1, right? T greater than 0. So here onwards I am having this graph.
Yes, sir, got it.
Okay, it's see here it's not in the multiplication sense wise we are writing. It's say here we are considering that in the sense of your product of this unit step functions as well as this functions f of t into h of t minus a, where this a is here it is 0. So 0 onwards it is there. Okay,
Yes,
from the
sir.
actual flow of the function sin t, so 0 onwards here we are considering. That's the point. Okay, pa. Now in this way we can write, right? This is my f of t. Here we return this f of t as in terms of your what I can say here step function. So what about Laplace transform of it? Read the problem carefully. Read the problem carefully. So find express this f of t in terms of unit step function and find its Laplace transform, so that here I am going to ask this theorem. Okay, since f of t minus a into u of t minus a or h of t minus a is nothing but this a I can take out e raised to the power as e raised to the power as remaining L as f of t. So this is e raised to the power minus as into this f of s is the result. So here Laplace transform of sin t we know that, sin 2t we know that. Okay, so that Laplace transform of in general this sin at means a square divided by s square plus a square. Is it clear?
Yes, sir.
Okay, then how can we apply the Laplace transform if it is in the both sides? We are going to find out the things. Laplace transform of this. Laplace transform of this. So Laplace transform of this f of t, then Laplace transform of this sin t, then Laplace transform of the product of these two things. Laplace transform of the sine 2t minus sine t into h of t minus phi plus Laplace transform of sine 3t minus sine 2t into h of t minus 2 pi. Okay, if we return this, then this is 1 divided by s square plus 1 square, right? It's very simple. This is my f of s. I may get this f of s. Okay, then here,
Sir, we can use convolution theorem in this case.
which one?
Sir, f of t and L of f of t into g of t can be written as f of s into g of s.
Are you saying that you are going to use that convolution theorem?
Yes, sir.
No, here convolutions part you cannot apply. So you are saying that Laplace transform of f of t convolute with the g of t is here we are having that. It is not convolution operator. It is in the form of product. Have you got the point? In L inverse, you are having that the product can be written as the product can be written as under convolution part we able to write. Okay.
Yes, sir.
Okay. So
Sir,
that
we have one direct formula for this, sir. L of f of t dot h of t minus a
L of
f of t into h of t minus a equal
is
to
what?
e power minus as Laplace of f of t plus a. No, sir, Laplace of t plus a, sir. F of t plus a.
Direct formula you are going to use.
Yes, sir.
So that is coming by shifting. Okay, if you know that, then it is easy. Okay, if you are using that, if you are going to use that, then that is also fine. So if you are using that, it is e raised to the power minus as. This can be written as. So here actually the concept is the heaviside function up to this 0. Then here my function whatever I am having that, okay, it will be have this f of t multiplied. So that, so it can be written as e power minus a. Suppose we are going to take, then it is f of what you are saying, that it is t plus a, right? Am I right?
Yes, sir. Yes, sir.
Okay, if you are using that, then what will be the thing here we are going to apply? This pi is common, f of t is whatever it may be. See here in this sense, this is t minus a, then only we can write in this way. But if you are having that any functions, it is not defined at two different points. It is t minus 0, it is t minus a. Okay, two different points, a 0, right? Two different points. Then if you are utilizing that, this t minus a, we may take this e power minus pi s, then Laplace of t plus a, you are saying that, right?
Yes, sir.
Then individually if you are computing this, what will be the answer for this? The sine 2t or minus sine t.
Sir, we get the sine 2t minus, sorry, plus sine t.
No.
Okay.
How you are saying that this is sine 2t sine 3t and all? Actually it has the amplitude 3, here it is 2, right?
Yes, sir.
Then how can you add that?
Sir,
Even this
instead of t,
even
we will
this
be
also you
writing
cannot
t
use
plus
direct.
2 pi.
Hmm?
Sir, instead of t, we will be writing t plus 2 pi
Instead of
after
t,
Laplace.
you are saying that Laplace of
Sine 3t plus 3 into t plus 2 pi
3 into.
after the Laplace transform, sir.
No. Here first, what you are saying that, okay, I'm not sure about whether it is right or wrong. Okay, whether even this also I will take. Okay, So just we may discuss. Okay, not an issue. Okay, this is Laplace transform of sine 3t minus Laplace transform of sine 2t, right?
Yes, sir.
So what is that?
Sir, sine 3 into t plus 2 pi.
Sine 3 into t plus 2 pi. Pi or 2 pi?
2 pi, sir.
2 pi.
Minus sine 2 into t plus 2 pi. Then we have to simplify this.
T plus. So why
2
you are
pi.
adding this 2 pi?
Sir, because here we had a h of t minus a. In this a was 2 pi, no, sir.
Okay, you are considering this one. Okay, so
Yes,
actually we have to solve for this first one. Okay, I think you consider this too. Okay, suppose if it is this term, if we are going to discuss. Okay, then t plus 2 pi t pi is okay, and this is also under Laplace transform, right?
Yes, sir.
As per definition, it is f of t plus a. Now we have to take this Laplace transforms, right? Then here it is Laplace transform of sine a plus b. Here Laplace transform of sine a plus b, sine a cos b, cos a sin b. We have to apply. Then with that, the product to some formula we have to consider, right? Am I right?
Sir, actually, this is after the Laplace transform, this whole term into e raised to minus 2 pi s will come, sir.
After the Laplace transform. Okay, then if you are adding, then and what purpose you are going to add this one?
So that is direct formula, no, sir.
No, direct formula.
So no,
We
we
have to find
using the
out. I
second
think
formula that
I'm
the
not
guy
given that.
used.
See, I think in this one, okay, I'm not going to given that. So I just very stricted with that shipping theorem property. If it is t minus a and u minus a means I am having these results. This a should take from the both the functions. So that if it is a is not there, okay, far from your argument, okay, suppose I am having that this is my f of t, okay, so here suppose you are subtracted and added, suppose I am going to have this one.
Excuse me, sir.
Yes, pa?
Sir, our next class has started, sir.
Yes, sir.
Okay. With this, I will stop and we will discuss. Okay. So that direct formula you may say it, pa, but not like that. Simply we cannot take. Maybe by the answer wise you may write. Okay, but the logical and concept wise we have to discuss. Then only we can write. Okay. Next class we will discuss. Next class is on Monday only, right?